Today we are going to talk about unit tests and unit test frameworks. I'm using NUnit and NSubstitute for a unit testing routine and suggest you to use it too. You can find a lot of information about NUnit and NSubstitute on their homepages. Try to Google it by yourself. In my presentation, I'll use pieces of code and illustration from book The Art of Unit Testing by Roy Osher. It's a really great book and I strongly recommend to read it for you. Automated tests are divided into two big groups. They are unit tests and integration tests. Integration tests test unit of work without full control over all of it, but with the using of real dependencies. What I mean? Integration tests can also test some external dependencies of code, some real dependencies like a network, like a database, or like threads, maybe some random number generators or something like this. There are some possible ways where failure point may be, and it's maybe hard to maintain integration tests properly. But today we are going to talk just about unit tests. Let's take a look what a unit test is. Unit test is a test based on a unit of work. It's very important to understand what a unit of work is. A unit of work is a piece of code. Pay attention that it's not just a method, but maybe like a group of methods or whole class that performs some noticeable state change over the code or over the system, like some changing of public properties, or maybe some calls to static methods, some changing of static variables of some external classes, or it may call some third-party libraries, or it may return value or throw exception if something goes wrong or code fails. Unit tests can be both handwritten or created with the using of unit testing frameworks. Let's consider a following example of handwritten test. We have a simple class called simple parser. Its main responsibility lays on its only method called parseInSum. It takes a string as a parameter. It performs an initial check of a parameter. If the length of a string is 0, it returns 0, as you can see. Or if string doesn't contain decimal separator, in our case it's comma, our code parse string and return a value. In the case if string contains separator, it throws invalid operation exception, as you see on the screen. Let's take a look on a test class for this unit of work. We have only one method called test return 0 when empty strings. Notice that the name of a method is as explicit as it needs. In the try block we create the simple parser and we try to parse a empty string. If result is not a 0, we just display on the console information that the test fails, and we'll in this way see what's going on the test environment. It's really simple, isn't it? Unit testing frameworks provide for us great capabilities for unit testing. Let's see what the unit testing framework actually is. Unit testing framework is actually environment where we write tests, where we can run the tests. It's called test runner, and where we can review the results of our unit tests. Here they are. As I mentioned, I'm using an NUnit framework. You're also free to use MS test framework, and any other tools that you can find on the internet or maybe on a Codeplex. NUnit tests, NUnit tools can be grabbed from NuGet packages, and also you need to install the test adapter for NUnit for Visual Studio IDE. NUnit framework can be both represented as a standalone application and be integrated into Visual Studio. What actually I recommend, it's really handy and nice to use. Just go to a NuGet, find there NUnit, install. Also you need to get an extension called NUnit test adapter for Visual Studio for a nice flow and to get the possibility to run NUnit test in a MS test environment and MS test window, as it can also be called. Let's go deeper into unit tests. Actually, there are some conventions in naming, in writing unit tests, and best practices, as they can also be called. Note that the proper name for a unit test, I suggest it as a Roy Osher. It's in the first part, it's unit of work name, then a scenario on the tests, and then expected behavior of a test. For example, we have a method called isValidLogFileName. In a scenario of bad extensions, we expect that it returns false. Also, we have a convention how to call unit tests classes. They should start as a name of a class on the test and with a suffix tests. Project for a test should be called like our business logic project with a suffix tests. You can see it in a table. Let's take a look on test framework features. From there we can separate the attributes. Test class is marked with a test fixture attribute. Setup method are marked with setup attribute. I'm talking about NUnit framework and about its attributes. We will later talk about what setups are. Now just let's pay attention on attributes. In a pair with the setup, we have such thing like called tear down, it's mean that some cleaning and tear down code is in that method. Also, we have possibility to perform some test cases over one method. Like in this case, we earlier have seen the test for a method is valid log file name. With the test case attribute, we can pass into this method a group of parameters like bed file name foo. It goes here, and our expected behavior is false. It goes in a boolean attribute place, and our single method is displayed like two separate tests. Simple test methods should be marked with attribute test. Okay, let's go. Methods that marked with a test case attribute are called parameterized tests. I'm not recommending to use parameterized tests because the intention of the test methods are not always clear, but it gives us the possibility to place in one method actually a lot of test variants. Please consider this code. You can pass three pairs of parameters here, and extensions that is under test, and expected behavior. In a assert section, we test the expected value and result. All tests should be written in a 3A test structure. 3A test structure, it means that every test should contain the arrange section where all setups take place, and also should contain two other standard section and the X section where actually we are acting over our code, and the assert section where we assert that our intention is fully satisfied or not. Actually, the asserts is what displayed in a window of tests. Let's talk about the setup and tear down for test class. Setup and tear down are the method that work for all tests in our class. If you create two methods with attributes one setup and one for a tear down, they will be run for every test that is on a test class. For example, if you are going to perform test on a method is valid file name, valid file lowercase returns true, and we create some setup method like to create log analyzer in a setup. Firstly, log analyzer will be created, then test method will be performed, and then on the tear down you can perform some cleanings. You may delete some shared resources or dispose some managed object or something what you need to do in cleanups. Now let's talk about code dependencies and isolation frameworks and some isolation techniques. We have such thing like step-by-step codization. Let's take a look on a test method. This test method is actually test file name. It reads through the configuration file and return true if configuration says extension is supported. On the very first step, our method is valid file name directly works with the file system, and it's real bad for unit testing. It's not we call unit tests. It's more likely that we have an integration test, but our intentions are to make this method work in an isolated environment. That's why we need to introduce some layer of dependency into our application. We create the file extension manager which will provide some feature for communication with the file system, like to take some file, or find some file and check it extension maybe. In the first step, we are going to create the interface called extension manager, which we will be used for introducing a stub to communicate with our method is valid. For purposes to introduce the layer of dependencies is used such things like dependency injection practices. There are several ways to provide dependency injection. It may be provided with a constructor injection, like in the first example. We just pass to a class constructor some dependency. In our case, it's extension manager, and then in our method is valid file name, we just use that injection. In our case is I extension manager. It also may be the property injection. We can set the extension manager from a property. In our case it's public property, not internal, and then in the method we can use it. But you should take into account that the introduction of dependencies with a property injection is not a real way that is sustainable for all variants, because it can be some moment when you simply forgot to provide the dependency into a property, and as a result you will get a failure with a null reference exception. It's not what you want to see in a production code and when you deploy your application. Also, dependencies could be provided with a factory in the injection. It's our third example. We have our class on the test, and also we have some factory class. In our class on the test, we call the factory method create and take our dependency called manager, set is as a field of our class, and then in the method is valid file name, we just use it. Also, we have some another way to introduce the dependencies into our code. It is called extract and override method. The idea is rather simple. We just create the class that is derived from our class under test, and in the method and then simply override the method getExtensionManager to provide the extension manager which we want for our purpose. In our case, it's purposes of testing. Let's take a look on two things called stubs and mocks. They are both fakes, and the difference between these two structures is not too obvious, especially for fresh guys in the testing. Stubs is that is a thing that we use when we are going to isolate our code from external dependencies. But please notice that assertion in test is not performed over the fake, in our case stub, but is over class under test. That means that you just isolate the code from the dependencies with the stubs. Another type of fakes are mocks. Mocks are provided to check if our class under test perform that communication that we are expecting to see from it, and we perform assert over the mock, not over the class under test. Is really important, and I hope you will understand it fully. Let's take a look on a mock example. Please notice that the mocks as actually stubs could be created with a test framework, but in our case, for simplicity, we will provide a full example with a handwritten mock object. Let's consider the following code. We have some class called LocAnalyzer. As an external dependency for it, we have the web service. Web service is perform such action as it log an error in the case with when a file name is too short. When we perform testing against the LocAnalyzer class, we are not going to test the web service because it's not what we are testing, and for web service we are going to have different tests. We are going to isolate our code from a web service. In the first step, we are creating the fake web service and pass this fake web service as a dependency injection into constructor. When we call the method analyze on a LocAnalyzer class, our fake web service, in case of bad file name, need to log an error, as I told earlier, and we perform the assertion against our mock. It is what about I was talking in the previous slide. Isolation frameworks. As you can see on the diagram, the most famous and most extensively used frameworks are the Mockio, RhinoMocks. Also, a lot of users don't use any mock frameworks or maybe isolation frameworks. They just use handwritten fakes and stubs. And Substitute, it's framework that I'm talking about, takes the 1, 2, 3, 4, 5th place. let's take a look on and substitute. And substitute is really great when you need some external dependency. In our case, it is a logger. In a case when you do not use any visualization framework, you have to create the mock manually. That's what it looks like. But if you're using and substitute, it's really simple. You just create the fake object with a substitute static class. You call method substitute and pass iLogger interface as a type parameter into it, and then on a logger object, as you remember is our substitute, we call receives method, and then call the call if that logger receive following calls log error. If not, our test will fail. Let's consider a little more complex code. We can build a really complex structures with a substitute. We can check complex logic. We can check what actions are exactly goes after one action and what goes after another action. We can throw some exception from our fakes and so on. As you can see, the benefits of using unit tests in a real life application are really great. You can get a precise information from Roy Osher book. Is a book about I was talking in the start of our presentation. Okay, thanks for attention. I hope you will subscribe my channel, and you'll be waiting for new videos and new information. Please follow my YouTube and follow on Twitter. Thanks.